Hello everyone, this is Sensei Jenny, your learning buddy today. For today's video, I'm going to discuss to you about plate tectonics, more specifically the three types of plate boundaries. Plate tectonics is a theory which suggests that the Earth's crust is made up of plates which move in various ways, thus producing earthquakes, mountains, mountain ranges, volcanoes, and other geologic features. Now, what are those three types of plate boundaries? But before we move on, if you are new to my channel, please don't forget to follow my Facebook account and subscribe in my YouTube channel, Sensei Jenny. And don't miss to click the notification bell for more videos. Moving on, there are three types of plate boundaries, which are differentiated according to the movement they exhibit. The first one is the convergent plate boundary. The second is the divergent plate boundary, and the third one is the transform fold plate boundary. Now, in convergent plate boundaries, the plates are moving towards each other. As you can see, there are two plates converging, both continental plates. Now, what are the possible results of the convergence of these two plates? The answer is, it depends. It depends on which type of plates collide, whether it's continental-continental, oceanic-oceanic, or continental-oceanic convergence. Now let us discuss it one by one. So this photo shows the three types of convergence, but let us focus more on this one, the continental-oceanic convergence. As you can see in this portion, one has a continental edge and the other has oceanic edge. It is clear that the collision of these two plates will give rise to the formation of volcanic arc near the continental edge. And why is that? It's because the oceanic plate, which is denser compared to the continental plate, will move towards the mantle. It will undergo the process called subduction. And what is subduction? It is the bending of the plate towards the mantle. Eventually, it will be consumed there together with the volatile materials due to the extremely high temperature in the mantle. What happened to the crust? It will turn into magma together with the volatile materials. Addition to volatile materials such as water will cause the magma to become less dense, thus allowing it to rise and reach the crust once again, causing volcanic activities at the continental leading plate. Now moving on to the next type of convergence, the convergence of two oceanic plates. Like the first type of convergent boundary, converging oceanic plates will cause the formation of trenches, and these trenches can be the source of earthquakes. Underwater earthquakes, especially the stronger ones, can generate tsunamis. Tsunami is a Japanese term for harbor wave. It is a series of ocean waves with a very long wavelengths. Now let us try to investigate the formation of our very own Philippine archipelago. Majority of the islands in the Philippines are considered as part of the Philippine Mobile Belt. These islands were formed 65 million years ago at the southern edge of the Philippine Sea Plate and are considered as part of an island arc. Aside from the formation of trenches and troughs, the downward movement of the oceanic lithosphere underneath the Philippine archipelago creates active volcanic chains. For example, the descent of the West Philippine Sea oceanic lithosphere along the Manila Trench created a volcanic chain from Taiwan to Mindoro. Some of the known active volcanoes in this chain are Pinatubo in Central Luzon and Taal in Batangas. Now what about if two continental plates collide? Well, in this case, a collision zone is formed. Unlike the other two, no subduction that will take place in this type of plate boundary. No trench, no volcano, and definitely no island arc. Instead, a large group of tall mountains is formed called mountain ranges. About 40 to 50 million years ago, two large land masses collide to begin the formation of the most visible product of plate tectonics, and that is the Himalayas mountain ranges. Since there is no subduction that takes place, the pressure is released by pushing the crust upward and forming Himalayas. Yes, there will be an earthquake in this type of plate boundary, but it would be a shallow one. Moving on to the second type of plate boundary, we have the divergent plate boundary. From the name itself, the plates diverge in this type of boundary, or shall I say, they are going separate ways, creating a zone of tension in the middle. And then the third type is the transform fault boundary, where the plates slide or grind past each other without diverging or converging. The best example of this plate boundary is the San Andreas Fault, which is bounded by the North American Plate and the Pacific Plate. These two types of plate boundaries will be discussed further in our next video. So once again, if you haven't followed yet, please follow my Facebook profile, Jaini Jan, and or subscribe in my YouTube channel, Sensei Jaini, Your Learning Buddy Today.